Welcome to Balco's AIA Continuing Education series. Today's AIA course is titled Firestop 101, an Introduction to Firestopping Technology. This course has been approved for one learning unit for health, safety, and welfare with the American Institute of Architects. Balco is part of the Engineered Building Solutions Group, a segment of CSW Industrials. The EBS group unites Balco, Metacock, SmokeGuard, and Greco. These four leading brands provide innovative, safety-focused solutions for architects, building owners, engineers, and contractors with a shared commitment to life safety by design. Balco manufactures high-performance architectural construction products for the commercial market, which includes a full line of expansion joints, egress systems, fire-stopping products, and much more. You can view our full line of building products at balcousa.com. Balco is a registered provider with the American Institute of Architects CES program. This course is approved and in compliance with AIA. This program is not intended to promote any specific construction material or method of use. At the completion of this video course, you will need to take our 10-question test and get 70% correct to receive your AIA Certificate of Completion. You will receive your certificate via email. If you are an AIA member and you provided your AIA member number, we will report your course completion to AIA CES records. Please allow for up to 10 business days to report credit to AIA. This presentation is copyrighted by Balco. Any reproduction, distribution, display, or use is prohibited without written permission. This course covers the fundamentals of Firestop systems, including the three components of balanced fire protection and the two primary Firestop conditions. You'll learn how Firestop materials perform, where and how they're applied, and how to properly specify them. We'll also walk through inspection best practices and common troubleshooting techniques to ensure code compliance and system reliability. Today's presentation was recorded by Steve Cooper. Steve is Vice President of Promotions and Training for Balco. Steve works directly with architects, specifiers, and distributors on product education and project specifications. With that, let's turn it over to Steve.
The balanced approach to fire protection is a combination of detection, suppression, and containment. Detection are things like smoke alarms, fire alarms, carbon monoxide detectors. Suppression are active items like water hoses, sprinkler systems, fire extinguishers. Containment are construction materials like fire barriers, smoke barriers, and fire stop systems. Together, these systems provide a balanced approach. The active side are sprinklers and alarms, so they notify you and work to put the fire out. The passive side of it stops the fire from where it begins and keeps it from spreading throughout the structure. Smoke is the most common contributor to fatalities in a fire. The reason why is because smoke travels quicker than people think. Under several studies, the smoke has been determined to travel at 120 to 420 feet per minute. That's about 3 to 5 miles per hour, which is a brisk walk to a jogging pace, if you're outside or on a treadmill. That's just not practical to do in a building that is in an emergency situation. And if it's a smoke-filled corridor full of people trying to escape, you can't move at that speed. And so smoke overcomes people in those instances. So using the calculations that were made from the previous slide, if you consider a 20-foot by 20-foot room that has a high ceiling, and there is a separation into two parts of the room that are completely sealed off from each other, and you put a pencil hole in that wall that separates the two structures, when one room starts to fill with smoke, how long do you think it takes to fill the other room? In a little over 3 minutes, you can't see your hand in front of your face. That's how fast smoke travels. And the reason why it travels that way is because it's trying to find equilibrium. There's pressure in the room, and it's equalized between the two rooms, whether that's equalized through air conditioning equipment or whether it's just general air, but the rooms are equalized. And when you start to have smoke fill one of the areas, that creates a volume, and that volume creates an imbalance, and that volume is trying to find some place to go to rebalance itself. So it looks for any kind of opening, a pencil hole, a hole where there's a plumbing pipe, a hole where there's a joint, gap opening in the wall, maybe for movement, or gaps in gypsum materials or concrete or any of those kinds of things. a gap between the drywall on the wall and the floor. It looks for any of those kind of areas to go through it. If it has an opening, it's going to migrate across. So the objective for Firestop is compartmentation. Compartmentation contains the fire, smoke, and toxic gases in the area of origin, keeps it from spreading throughout the structure. This is a diagram of a structure that has been laid out so that it has fire and smoke cavities. So fire barrier materials are in red and smoke materials are in blue, and those are construction materials, whether that be a concrete floor or whether that's a gypsum wall or roof material or whatever it is that separates these items out, so that if the fire does start out in one area, it is blocked from traveling across to other areas. There are two kinds of openings in a structure: linear joints, which are gaps in the structure, and penetrations, which is any place that the construction requires some sort of an opening in what would otherwise be a completely fire protective wall or floor, so that they can place utilities in HVAC and plumbing and electrical and things of that nature. Here's some good examples of what containment is all about. In 1980, the MGM Grand Hotel had a fire in the basement, and the smoke spread throughout this whole 26-story structure, and there were a lot of fatalities. That led to a lot of building code developments. 1995, 15 years later, the ICI Imperial Chemical Plant in Yorkshire, UK, had fire containment built into the design, so it was compartmentalized. And the fire broke out on one story, and it was contained into that opening until firefighters were able to arrive, and they were able to evacuate people out, and they were able to complete that construction, and the building didn't have to be demolished. So there's your origins: the basement of the MGM Grand, and then the third floor of this Yorkshire Imperial Chemical Plant. You can see that there was minimal damage in that Yorkshire plant. And one thing I want you to notice, so the rectangle area is an indication of the fire-rated barrier in the structure. And all of those studs that you see going around there, those are smoke partitions. So there are multiple levels of protection inside that. So not only is there a big rectangle that is fire rated, but individually inside that, there are also smoke control systems in place to keep the smoke from traveling. So the way these systems get implemented into structures are through building codes. The International Building Code, the International Fire Code, NFPA, the National Fire Protection Agency, they develop codes for the structures, and those codes reference test standards, which provide credentials for the materials that are used to make sure that they are going to perform properly. And so a good example in here are different types of joints and penetrations and the types of codes and standards that are required for those. So head of wall and bottom of wall have International Building Code 715 and International Fire Code 704, and they have test standards UL 2079 and ASTM E1966. And they are also specified in architectural specifications in a building design. So the specification section in this particular case is 078443, which would be fire stopping for joints. And then there's also an inspection standard that the building inspectors use to review the documentation in the structure and to make sure that the structure meets the proper test standards, and that is ASTM E2393. So the joints, which would be head of wall, floor to floor, curtain wall, they all have very similar standards. Curtain wall has a separate test standard. It uses an ASTM E2307 standard. And then penetrations, which is where they puncture holes in the structure to allow utilities, that has its own test standards, UL 1479 and ASTM E814, and that's a specification section 078413, and it has its own inspection standard, which is different than the joint standard, ASTM E2174. So all of these entities work together to ensure that the structure is designed to meet all of the standards that are required to make sure that this is a safe structure. The performance of Firestop is determined by the way it acts when it is enabled in a fire situation. For instance, intumescent technology is where a material swells up when it gets hot and it fills a void or a cavity. Elastomeric is the elasticity of a product. So when it's hot or when it's cured and in the structure, it allows expansion and contraction of the building component. An endothermic is where it draws heat out of something like a metal pipe. If you have a metal pipe going through a wall for plumbing purposes or something like that, when the pipe gets hot from a fire, the endothermic material pulls heat away from the pipe to absorb it into the materials that are keeping it from passing through and creating heat on the opposite side from where the fire is at. And there are hybrids that have any two or more of these characteristics combined. You'll see many examples of these as I go through the presentation, but products for areas like head of wall, which is where a gypsum wall would meet a concrete floor, something like that, they're going to be allowing for more movement. Plastics for penetrations would have more intumescent capabilities, and metallic penetrations may have more endothermic capabilities. So here's an example. An intumescent material changes shape. It grows, and it usually ends up charring, so it gets kind of like when wood burns, it gets that black char on it. What usually happens in intumescence is they do a very similar thing. They actually expand and gain volume. They get bigger, but they also char to block heat. You'll see some great examples of this as we go along through here. Elastomeric, again, high temperature, but it's very, very stretchy. So it allows a lot of motion to happen in the structure. In endothermic is where the absorbing of heat takes place. There's a really good example of an intumescent material in action. So this is a box guard insert inside an electrical box. It's just being staged, and there's a torch being applied to it to see what happens. So that box guard was 1/4 of an inch thick when we started out. So they just started spraying heat directly onto that intumescent, and you can see that material glowing. So this is a constant flame being applied straight to the intumescent material, and you can see what it's doing. It's just filling that complete box in. So when it fills it like this, it's keeping the fire and the heat and the smoke all from making its way through that electrical box to the other side of the structure, which is where the electrical plugs would be or whatever. And once the flame's removed, it's self-extinguishing. That's that char that I'm talking about. It just creates a shell on there and nothing else gets through it. And on the right-hand side is an elastomeric action. So this is a corrugated concrete deck in a cycling machine with a gypsum wall, and that is simulating the deflection of a concrete deck bouncing up and down as people walk across it or cars drive over it or whatever happens, so that there's a relief allowed to keep that gypsum from being crushed or cracking or anything like that. So the fire stopping materials will be placed in between there. So one common misconception that we see in the fire stopping industry is that fire stop material, which might be a sealant, a red sealant, or a spray material, or some kind of a tape or strip, that is a fire stop or a fireproof material by itself. But that's not really true. Really, it is one component of the overall construction, which would be the fire stopping material, the penetrating item like a pipe or electrical box or whatever that is, or a joint opening, and the construction of a wall or a floor or whatever those materials are, whether they're concrete, wood, gypsum. All of that is tested together as an assembly, and that's what's actually rated. The assembly itself is what's rated, not really the material in the tube that you might buy, a case of tubes of some type of sealant or something like that. That's just one component of it. These test standards are introduced and in place through the American Society of Testing Materials. The American Society of Testing Materials has responsibility for writing the standards. UL, Underwriters Laboratory, also has a similar standard that they write, but UL, in addition to writing a standard, which either they use ASTM standard or they write their own standard, and most of the time, if there are two standards, those two are synchronized so that they have the same language in them. And then UL also has a testing facility where they can carry out the tests and provide listings that you'll see examples of, that are basically the credentials of the methods that were used for any particular type of application. So a good look at some testing equipment on the top left is a horizontal furnace. We'll call that a floor. What you're seeing right there where the arrow is pointing, and you see that rusty metal right there, that's a concrete slab that's been pulled up in the air. And underneath there, you see all those pink items. Those are red hot pieces of metal. They're some type of tubing or electrical or piping or something of that nature. Below that is a furnace. So those were lowered down in the furnace and then fire tested and lifted up. And then similar situation on the walls. These are both small scale furnaces. They're about 4 feet by 4 feet, but there are much larger ones. Some are 12 feet by 12 feet. There are different sizes out there in the industry, depending on the kind of application. Some are even larger than that. Some are 2-story structures, like for curtain wall and perimeter joints. So they test for several different things when they do a fire test for fire stopping. One is a test for flame. So that would be to make sure that flame on the hot side where the furnace happens is never visible on the cold side, which is where if you were viewing this fire test, you would see nothing but a gypsum wall, and back behind that would be all the heat in the furnace and all that cooking on the back side of it. They want to make sure that no flame ever is visible on the cold side of the furnace. That would be a failure. The next would be, depending on the type of test, whether or not there would be a temperature. So in different cases, depending on what the type of test it is, this temperature would be measured to determine how much it grew from the hot side where the oven is onto the cold side, to make sure that it didn't get to a temperature rise that would create a failure point of the test. And all of these are done to some kind of time frame. So the time frame would be something like 1 hour or 2 hours or 3 hours. And for that duration, if there's no flame showing for that 1 hour or 2 hour or 3 hour test, then that passes. Same thing with the temperature. The temperature would have to not rise above a certain point, in this case 325 degrees, in that 1 hour or 2 hours or 3 hours, depending on what kind of test. And quite often, fire tests for fire stopping materials may require the time frame for the F rating and the time frame for the T rating to be the same, but they're not always that way. So it may be a 2 hour test for F and T, where it might be a 2 hour F and a 1 hour T or something like that. There are different variations that happen. So you'll see all that in the listings, and it's okay to do those different variations depending on what kind of test you're conducting. Another one that is conducted in fire stopping, in penetrations, the horizontal and vertical items are exposed to a hose stream test. So they shoot it with a fire hose. You'll see a good example of this as we go along. They shoot it with a fire hose on the hot side of the furnace after they've burned it for whatever time duration. And if there's no visible water on the face side, the cold side, then it's passed the hose stream test. And on the joint applications, which would be perimeter joints or expansion joints or control joints or whatever those kinds of joints are, the hose stream is only conducted on the vertical joints themselves. Are not conducted on the horizontal joints. And then there's some optional kinds of testing that are done. M rating, which is a movement, but it's really not like movement for expansion and contraction of an expansion joint. This is really something more like the movement of a pipe in a wall, or vibration or pipe hammering or something like that would happen. And it could be related to seismic motion, but it's generally related to penetrations. W rating is for a water rating. So this has got a particular standards to make sure that this product would hold up to a certain amount of water for 3 days. So 3 feet of water pressure attached to a floor assembly that would be in place for 3 days. And if it doesn't leak, then it has passed the W rating. And then an L rating is an air leakage rating, but generally speaking, that L rating is used for the passage of smoke or toxic gases. So if air doesn't get through, then smoke and toxic gas do not make it through there. And so there's all these different kinds of ways that they check to ensure that this works. Another type of test that's done in fire stopping are acoustic tests. So most fire stopping has some kind of an acoustic rating as well, because if you have a floor or a wall that has openings or joints in it, you don't want sound just transferring freely through those openings. So when it's sealed up with some kind of fire stopping material, that should deaden the sound and keep the transfer from one side to the other at a reasonable level. And so these are measured by either STC, which is really the indoor rating that's most commonly used in fire stop applications, which is sound transfer class. There's another rating called OITC, which is outdoor indoor transfer class, but that's not used very often for fire stop. So this is a good example of a bunch of different kinds of penetrations in a concrete slab that are about to be tested in a fire test. So you can see all different kinds of things. There's cable trays mixed with insulated pipes, conduits, there's metal pipes, all types of these in one apparatus. And it looks like to me maybe even some PVC pipe back there in the back. So they're really going to test a whole lot of stuff in this one kind of application to see how it does. So after a test like that, when you pull the floor material, the concrete, off the furnace and lift it up, what you're looking at are the materials that were being fire tested. And so on the right-hand side, where it looks like a bunch of different strings and kind of fringe looking, you can see kind of a flat area there. That is a cable tray where there's electrical passing through a floor. And then all of those orange-looking round pieces are metal pipes going through the floor. After that's all done, in a penetration or in a joint, in this case, in a gypsum wall apparatus, Once the material has been fire tested, they remove it and they spray it with the high pressure fire hose. And if there's any visible water on the other side of the opening, which would be the cold side, this is the hot side that they're spraying. But if there's visible water through the face of the other side, then it is a failure, which is a very tough test. So this is a PVC pipe. On the left, you see the cold side. There's a Firestop collar in place and a pipe running through that opening. All those little wires are temperature gauges, thermocouples. And after the fire, on the hot side, which would be the opposite side of that, where it was burned, you can see where the pipe has melted away and the intumescent has completely filled that cavity. When they construct a building and they put fire protection in it, there's concrete floors, gypsum walls, block walls, roofing materials, all sorts of items that are put in place to contain those areas for the fire. But when you start putting joints and penetrations through there, well, it's opened up like Swiss cheese. And so the fire, the smoke, the heat, everything would just travel throughout. So all of that is replaced, like you're seeing here, where there are Firestop sealants, pillows, putties, all different types of materials used to seal these openings off for all different kinds. And this can be concrete, it can be block, it can be wood, it can be gypsum, any kind of materials like that. It can be anything from a single pipe to, there can be plastic or metal, to these things all gang together like you saw in some of these fire tests where they have multiple penetrations going through one single opening. And there can be joints all around the structure, at the edge of the walls, across through the rooms, from the ceiling to all the way to the floor, from the roof all the way to the basement. These can be open any way that you can imagine. So what kinds of materials are used to solve these sort of penetrations and joint and openings that happen in a structure? How do you bring something back once you've drilled holes all through it, opened up gaps all in it? How do you bring that back to a fire-rated state? Well, different kinds of materials are used. In the case of metallic and small to medium-sized non-metallic pipe penetrations, so where they're putting PVC or CPVC, like would be sprinkler pipes, or any other kind of pipe. You could have aquatherm where you've got, high pressure water or something like that. You could have duct work going through these openings. They're usually some type of sealant is used to fill those kinds, or some type of wrap. And so what's the difference between a sealant and a wrap? Sealants by themselves will handle some smaller size plastics and some large metal. But when you need a large plastic pipe, they start going to kind of the more of the wrap type materials, which are a pre-cured intumescent strip that acts like that material you saw burning in that electrical box. And as the pipes get larger and the plastic pipes get larger, then there are more robust intumescent materials that are used, like collars around pipes or sleeves that wrap around pipes, so that you can get up to some pretty large pipes in that 6 to 8 inch diameter range. Many times the construction is better suited when the holes that are going to be placed are actually pre-engineered and pre-designed by the architect and placed so that they know exactly where the plumbing penetrations are going to go, instead of pouring concrete and drilling out holes and cutting through rebar. You can actually cast these in place as long as you have pre-located where all your pipes are going to go, and you can put these cast in place devices in, which have intumescent materials built into them. The pipe runs through there, and you don't have to do any core drilling or anything like that in the field. Electrical boxes are also considered a penetration. However, they are a little bit different than the penetrations you've been looking at so far, which we would call through penetration. So that's where a pipe would go through both sides of a wall. Electrical boxes typically only go through one side of the wall, right? You don't have an electrical box going through both sides. You might have back-to-back boxes so that it ends up lining up. But generally, these are called membrane penetrations, so they only penetrate one side of the membrane of the fire-rated construction. These can be managed with putties are the most common. Putty pads are the most common. It's a square piece of very pliable material. It's very sticky. It's kind of like Play-Doh, and you can wrap it around the box and it seals it all off. But you can also use box guards and cover guards and all different kinds of things to fill those boxes in place. One of the good things about these particular group is a putty pad you can put on before the gypsum is in place on the wall, and you get the box in there all covered up. But if you happen to be in a later stage in construction and you didn't get the electrical box covered with a putty material and the gypsum was already in place, you can actually still fire rate the box from inside the face of the box. You just put a box guard inside there. And if you had the gypsum in place and the electrical wiring already in place, you can actually put a box guard, which would be a type of box guard, which is called a cover guard, underneath the cover plate of it, and it seals that off and creates all of those create the same fire rated standard for an electrical box. And it's not only these small electrical boxes like 4x4 boxes, but you can actually do large boxes like the control panels, med gas units, and things of that nature too. You can do some quite large ones. Pillows and putty sticks are used for doing various kinds of openings. Pillows are more of a large opening kind of installation that's removable, and a putty stick is generally used like a putty pad, except it's in a tube form, and you just pinch off the amount that you need, and you place it around the opening, and it's commonly used in electrical cables and things of that nature that are just sort of those small one kind of location type items. You can have very, very large openings that you have to fill in construction for fire stopping. So you may have an opening. This is really common in cable trays, which is where you see where the pillow applications take place there. People like pillows because they're removable. So if you increase the size or add more cables to your cable tray, you can pull out a pillow, or you can add a pillow if it's taken down or something like that, and you can modify it once it's in place. More permanent solutions would be composite sheets, which are large 3-foot by 3-foot stainless steel sheets with Firestop intumescent materials applied to them, and you can stitch them together and create quite large openings that you can fill in. Or you can use fire-rated mortar, which can be used horizontally or vertically, and that's just like concrete material, except it's completely fire-rated, and you can core drill through it and run pipes through it. Or you can place pipes in there and then pour the concrete around it and seal it all up. Curtain wall and perimeter joints. So we're moving from the penetration side of things to the joints that happen in the structure. And joints are generally used for the movement of the structure. So it allows, like in this case, in a curtain wall, where you have a glass glazing system attached to a concrete floor at all the different levels of a structure, maybe a high-rise building. Wind blows across that curtain wall and it creates a deflection and motion. And this area is allowed, this perimeter joint is allowed to make space for that movement to happen. But you have to fill that in to keep fire from penetrating and traveling through that opening. And it has to be filled in with a material that is flexible. And generally, a Firestop spray material is used in those kinds of applications. And on the bottom right there, where you see that flame, that is a Firestop test apparatus. It's a 2-story apparatus that's used for testing curtain walls. And so there's a fire set on the inside of the structure that tests the floor portion of the Firestop perimeter joint. And then also a flame is placed on the outside face of the curtain wall to determine how quickly the fire moves up the face of the opening. Head of walls use sealants and sprays quite often. Head of wall joints are where the gypsum moves up to a concrete deck above. So that picture on the top left or the picture on the bottom right, that's where a movement joint is allowed to allow the floor up above to compress up and down on the gypsum and keeps it from cracking and things of that nature. But the most common method used in fire stopping these is some type of mineral wool backing material placed inside the cavity, and then it's sprayed over with a red or white or different color Firestop materials. This is a good example of what I'm talking about. So the floor on top, which would be the gray rectangle on the top left picture, would indicate a 1-inch gap that allows movement of that deflection of the floor material. And then on the right-hand side, it shows it being depressed down 1/2 of an inch. So it's compressed. And the Firestop material has to allow for that and to bounce back to the original 1 inch or whatever the range of motion is for several cycles to determine that it will stay in place over the life cycle of a building so that it's still intact when a fire takes place, that it still does its job. There are all kinds of joints in structures. Control joints and expansion joints happen throughout structures most of the time. These are either complete building separations or they're separations in building materials, and they have to be filled in with something. If they're fire rated, they have to be filled in with some type of fire rated material, which would be either a Firestop sealant or it would be filled in with a Firestop pre-cured material, like in this case, a joint strip material, which is a wrap type style material that we looked at earlier. Those instances were around a pipe. This is actually being installed in a linear joint with a backer rod and then Firestop sealant. So here's all the things you need to consider as you're working on choosing the proper listing for your application. So what's the assembly you're penetrating? Is it a wall or a floor? What's the thickness of the assembly? Is it a 4.5-inch concrete slab, or is it a corrugated slab? Is it a 6 1/8 2-hour gypsum wall with 5/8 Type X gyp on it? What's the hourly rating? Is this a 1-hour wall or a 2-hour wall, or is it a 3-hour floor or whatever? What's penetrating that opening? Is it a pipe or a cable, or is it, some sort of air conditioning and heating? Is it conduits for electrical boxes? So what are the diameters of these penetrations? So are they going to be, small or large openings, small or large pipes? And the hole, is the hole the same size as the pipe? Is it slightly bigger? That affects the amount of space around the pipe for the amount of material that you need to put in, or the type of material that's used in that. Is it going to be a single penetration opening, or is there going to be multiples, lots of different things in one opening? What is the shape, the annular space? Is the pipe in the center of the hole? Is it offset to one side? Is it completely contacting all the way around? And what kind of material would you prefer, depending on, now that you know a little bit about it? Do you think it's going to be a plastic pipe with an intumescent sealant? Is it going to be a joint with an elastomeric? Is it going to be a metal pipe with an endothermic? Is it going to be a hybrid that does all these things? And then what size? If it's an expansion joint, how big is this gap? Is it 1 inch or 2 inch or 6 inch or something larger? And then how much does this gap move? Does it move a small percentage, like 10%, or does it move more, like 25 or 50%? And will this be exposed to moisture? Is it going to be rained on, or is it going to be temporarily getting wet during construction phase? Those kinds of things you need to look for, all those items. That's a lot to remember, but I'll show you how the path works. So when we inspect fire stops, there are a couple of things that this serves for, and that is, one is that there's evidence of compliance, which is where we're going to be looking at how do we know that this fire stop application was done properly, and what is the document being used to do that. You'll see on the bottom right, there's a sticker there. It's a label that can be placed on a wall or something like that that says, hey, by the way, this was fire stopped in this method with this kind of number, and here's who you contact if you have any questions. One of the things inspectors look for is to make sure that the listing, which I'll walk you through in a minute, states the types of materials being used. In this case, that orange pipe is a CPVC sprinkler pipe. That material can be affected by different kinds of chemicals, and in some cases, the chemical reaction can produce problems. It can create pinholes or cracks and have a negative chemical reaction, creating a breach in that pipe, which loses air pressure, which means the sprinkler system doesn't work anymore. So one of the things inspectors look for is to make sure that the material is compatible with the construction. And the document that they use to verify all this is usually done by one of a few different listing and labeling agencies out there. UL, Underwriters Laboratories, is one of those. Intertek Listing Agency is another one, and there are several others out there. But the primary two are UL and Intertek, and UL's the most common. And so UL's got a naming system that is used quite widely throughout the fire stop industry. And so I'm going to walk you through how those work. So in this case, this is a penetration type of listing, and there are indicators of what this is being used in. And so, for instance, the red lettering, WFC, wall, floor, or a combination of floor or wall. It could be either one. So it's an indicator of what's the orientation of this item that we are testing. The second one is what's it made of, LCAJ. So if you look in the blue lettering here, you can see that an L is a framed wall. Right? A C is a framed floor, or an AJ would be a concrete floor, or a masonry wall could be a combination, could be either one of certain thicknesses. The green lettering tells you what the metallic or what the penetrant material is. So the next letter, so if you look at the top one, W wall, L framed, 51, it's in that 5000 series, that's an insulated pipe. So it's an insulated pipe going through a framed wall, and that the black numbers, the 30 is just a sequential number. That's the 30th test done in that type of combination. And so that's the way you walk through the kind of listings. And then this is what a listing looks like. So in this particular case, it's a CAJ. So it's a combination. It's a concrete or masonry wall, according to the AJ. It's a 12, which is going to be in that 1000 series. It's a metallic pipe, conduit, or tubing, and it's the 35th test in that series of the kind of tests that were done for this. And so that gives you a graphic illustration. It gives you indicators with all these numbers that tell you what that, like the circle with the 1 is going to tell you that that's concrete of some thickness. The 3B is going to tell you that's a fire stop sealant of some type. The number 2 is going to tell you that is some type of pipe being placed in the opening. It'll give you sizes, ranges, and then the listing itself will give you the hourly ratings. It'll tell you if it passed an F rating, an F and T rating, an F and H, which would be the hose stream and fire. If it had an L rating, this particular one had just about everything. It's got a W rating. It's got almost everything you can have in a single test in there. And so that gives you all these indicators of what this is qualified for. Joints are similar. The layout of the numbering system is similar, but the representation of the characters means something a little bit different. So in this case, we're going to look at an HW, which is a head of wall. So that's where that gypsum wall meets that concrete deck above it. In this case, it's a corrugated deck. D stands for dynamic. So it can be a dynamic, which means it's a moving joint, or S for static, which means it's a non-movement joint. In this case, it's a dynamic one. It's a 0, 0. So the joint is going to be in that 0, 0 through 0,999. So it's going to be less than 2-inch wide opening. And again, the black numbers are 32/32 in the series of tests that were done in this particular type of configuration. So this is what a curtain wall listing looks like for UL on the left and for Intertech on the right. So you can see they're very similar kinds of characteristics. They show the makeup of the materials. They show all the different types of ratings. They say all the same kinds of things. They tell you the test standards is tested to, what the materials are used, and all that sort of thing. When you have a joint, it's tested to something else besides just what I mentioned earlier about the different kinds of materials and the heat and all that. It's also subjected to cycling so that it has to move a certain amount of before it is qualified to pass the movement criteria so that it can move on to all that fire testing, which is where we have the flame and the thermal and all those different kinds of ratings. So it can be cycled 500 cycles at 1 cycle per minute, which gives it a thermal rating. Or wind sway is 10 times that fast. Seismic is 30 times that fast. So seismic, this material would cycle through its nominal size to its maximum, to its minimum, back to its nominal in 2 seconds. So that's pretty fast. So seismic is very, very quick. Or there's some combined functionality that the testing labs do that say, if you do this combined, we'll give you all three of the thermal, wind sway, and seismic. So let's say you're in a project and you've got a non-conforming application. You can't find a listing anywhere that meets the criteria that you have in your particular building. What do? You generally go to an engineering judgment. And an engineering judgment is a guideline. And there are guidelines posted by the International Firestop Council that give you an indication of how these judgments are supposed to take place. So there are some criteria that the writer of an engineering judgment must go through. And then a building inspector or authority having jurisdiction has to approve this application. So this is an example of a pretty typical engineering judgment. So this was in a wood floor application with a gypsum base. It's got a membrane penetration where there's a pipe coming through, and that's probably going to be something like would happen with a shower drain or a toilet fixture or something like that, where you're going to have plumbing running through the inside the joist areas and then up through the floor to get access to some area in there. But you can get engineering judgments from the manufacturer. They have qualified people on staff to do this and designated people. You can get it from a professional engineer or a fire engineer or a qualified testing agency like UL or others have got standards that anyone interested in writing engineering judgments can go through. They can take a test and they can become a qualified individual to write these. Not every jurisdiction will allow engineering judgments. Some say they're not. So what's your alternative if you can't do an engineering judgment? Well, then it becomes the owner's responsibility to make sure that the building meets some type of fire tested system. So they may have to modify their structure to meet one of those, or the next would be the owner typically would pay for a test to meet the kinds of construction that they have in their project that have never been done before. And that can take a long time. It can be quite expensive to do. But those are your two methods. You either make the building comply to something that exists already, or you do a fire test to confirm that what you have will actually pass. And if it doesn't pass, then you've got to go back and modify the building until you find something that passes. So now moving on to specifications. So the specification areas for Firestop, the general section that is used in the CSI master format is 078400. That's the primary section for fire stopping. There are two categories in there. One's for penetrations and one's for joints. So 078413 is penetration fire stopping. 078443 is for joint fire stopping. And so most of the time, specifiers will have those two sections identified. Expansion joint applications actually have another section that includes other items besides just the fire resistance characteristic. It also includes structural joints and waterproofing and a bunch of other things like that. That's really not the topic of this particular conversation, but it's worth noting that that is an 079500 series of specifications. So this is a wordy slide, but the short version is Make sure that you match your 078400 specification to anything that would be happening in your other sections related to either fire stopping, plumbing, HVAC, electrical, telecommunications, all those kinds of things. Coordinate all those with your 078400 specifications. In your general notes, Firestop all penetrations through fire-rated walls and floors with an approved Firestop system. That's just a fundamental line to put in your specifications that says you have to Firestop all the openings and all the joints. That's just the way it is. If they're in a fire or smoke rated in part of the construction, you need to bring them up so that they have an approved system in place so we know they're going to work. That's the main thing. And then inspections. So the inspection of these joints and penetrations for fire stopping are not mandatory in every kind of structure. They're mainly related to risk categories 3 and 4, which are really high occupancy or kinds of occupancies that would be for safety or something like that. So it might be a tornado shelter, or it might be a nuclear facility, or whatever those kinds of things are. But if you do not have a standard to go by, these are still the best standards out there. They are the most reliable types of standards, and that is what is taught to most Firestop inspectors and building inspectors. So even if you don't have a risk category 3 or 4 structure, the best guideline is still to use the ASTM E2174 for penetrations and ASTM E2393 for joints. If you put that in your specifications, somebody's going to have a really excellent guideline to walk through your structure and do a really good Firestop inspection. And lastly, feel free to put the drawings of the types of penetrations that you have selected. You can pull them right off of the listings. You can get them from manufacturers. They supply these freely to you so that you can have these items addressed in your construction drawings, so that you can place these in plumbing or electrical or wherever they fit, HVAC, or you can just put them on a general fire stopping page, however you like to do that. But these are very, very good to have in place, because then it makes it just completely clear what your intentions are in fire safing your structure, and including Firestop as a part of those assemblies.
This concludes our AIA Continuing Education On-Demand presentation. On behalf of Balco and the EBS Group, thank you for your time and attention. To receive credit for this course, you'll need to complete a 10-question quiz. Simply click the test button below to get started. A passing score of 70% or higher is required. If needed, you can retake the quiz as many times as necessary to achieve a passing score. Once you pass, your AIA Certificate of Completion will be emailed to the address you provided before taking the quiz. If you're an AIA member, we'll submit your credit directly to AIA on your behalf. Please allow up to 10 business days for your credit to appear on your AIA transcript. The EBS Group offers AIA-approved courses on life safety products. Balco covers expansion joints, photoluminescent egress systems, and fire stopping. Smoke Guard focuses on fire and smoke protection solutions. And Greco offers courses on commercial architectural railings and code compliance. Scan the QR codes or visit their websites to explore all available courses. If you have any questions or would like more information on Balco, visit our website at www.balcousa.com. Thank you again for your time and interest.